Hey there, Assalamu alaikum. So today we have this amazing problem from projectile motion. This is a quite classic one, but it is very interesting. I mean, even if it is quite classic, it is quite interesting. So what does the problem say? It says that suppose that there's a particle that is being projected from origin with a certain velocity u at a certain angle above the horizontal line. Now, let's say there's a target point situated at, let's say, x comma y at P, which is of course in the same vertical plane as the projectile's motion. Okay. Now, we have to figure out the minimum velocity that is required to hit that object. So it kind of makes sense that there will be a plethora amount of velocities for which we can hit the object, and for those different velocities we'll be having different angles with the horizontal line, but we want to figure out the velocity that requires that is the minimum velocity, so we want to figure out the minimum amount of velocity. Okay, now then we need to figure out the theta that will be our angle of projection, that is whatever angle that we are creating with the horizontal line while throwing the object, and we will also need to find the time t that the particle takes to hit the target at point P. So, well, this is a very classic one, but very interesting. So, without continuing with the rest of the video, I would urge you to do the problem by yourself. Give it a lot of time, I guess. I mean, at least try it for an hour, at least. And if it's not still happening, then watch the rest of the video, because our thinking capacity only grows if we give our best at trying the problem at our hand. So give it your best shot. And okay, if you have given your best shot, then let's proceed with the solution. So we will be solving this problem in two different methods. Okay, I mean, these two different methods are not quite that different, but the second one is quite shorter and I guess less messier. So wait for the second one. To start with the first one, I mean, this is a kind of brute force approach. Okay, so we are going to brute force the solution out of this problem. So we have to observe some things. What are those things? So at first, we need to understand that we are throwing the object at some valid angle theta. Okay, so we are throwing the object at some real angle theta, and we are trying to reach a point x comma y that is situated in the xy plane, or the plane of the projectile. Now, it is very obvious that we are going to use the famous equation of projectile that relates both x and y. So we know that y is equal to x tan theta, where theta is the angle of projection, and as half gx square divided by v square cos square theta. So this is quite obvious that we are going to use this equation, because in this equation we are getting all of the elements that we need. We are getting the velocity portion in this equation, and we are getting the relation between x and y, which is given. So this is given, right? This is constant. This is a given point. This is not variable. This is given. Okay. So we are getting the relation between x and y. We are having the relation between theta and v. So this is a very good point to start from. So now, if you have seen my previous video where I talked about another this type of problem where we have to apply the condition of figuring out the real values of theta. So in this equation, we have to plug in the real values of theta, right? So we need to figure out a way to ensure that we are only getting real values of theta. So how do we do that? We make um, we make an equation, a quadratic equation of tan theta, because for theta belonging to R, we get tan theta also belonging to R. So if theta is real, tan theta will also be real. Okay, so we are going to apply the condition of real tan theta value in this equation. So how do we do that? We try to make a quadratic equation of tan theta. Luckily, this format gives a very neat way to do that. So 1 over cos squared theta is nothing but sec squared theta, and sec squared theta can be written as 1 plus tan squared theta. So we have this right here. Now, as you can already see that we have something like a quadratic equation of tan theta, right? So we can neat it up, and that's what we are going to do. So half gx squared divided by v squared tan squared theta minus x tan theta plus y plus half gx squared divided by v squared, okay, is equal to 0. So this is a very neat quadratic equation of tan theta. Now we can easily figure out the condition for which we will only get the real values of tan theta, which is, if you look at it, this is a, the coefficient of tan squared theta is a, the coefficient of tan theta is b, and the rest is c. So we know the discriminant of this quadratic equation should be b square minus 4ac, and if this value, this discriminant, is greater than equal to 0, then we will get a real value for tan theta. So let's apply that. Let us apply that. X squared minus, well, 4 times half gx squared divided by v squared y plus, okay, wait, y plus half gx squared divided by v squared. So this should be greater than equal to 0. Okay, fair enough. So for this condition, we will get what? Real values of tan theta. Okay, so let us smartly copy this thing out of here, because we are going to get this to a fresh page. Okay, copy that, get to a new page, paste that thing, translate that thing to there. Okay, so as you can see, we have x squared in both of these terms, so we can cancel it out, and we can also do some simplification. After doing some basic simplification, we are left with something like this. Okay, we are getting the hang of it. We are getting the hang of it. Yes, sir. Yes, sir. Well, wasn't that supposed to be x squared? Yes, it was supposed to be x squared. The square is for some reason omitted. Okay, so this is what we have. Okay, now what we can do is 2g v square y plus g squared divided by v to the power 4 x squared must be less than equal to what? 1, right? Now what we can do is we can multiply everything with v to the power 4, v squared plus g squared x squared is less than equal to v to the power 4. This looks quite interesting, doesn't it? So we have another equation for v. Okay, so let's give it a look. Okay. So this is yet another equation which is sort of like the previous one. But from this equation, we can get a value of v. Since this is also an inequality, so we will be getting a range of v. And from this equation, we will actually get the value of minimum v. So how do we do that? Let's solve for v squared. We know for v squared, this thing, let's put it there, okay, plus minus, of course, my bad, plus minus 4g squared y squared plus 4g squared x squared. Well, that is quite nice looking thing over there. Okay, so we divide it by 2, and then v squared is equal to, let's do some simple calculation. You can get 4g squared out of this square root thing, so then that will become 2g, and you can divide the 2 using this 2. So what you get is g y plus minus root over x squared plus y squared. Now, since x is always greater than 0, I mean x will be equal to 0 only if you are throwing the object vertically upward, which you are not doing this in this scenario. Even if you are doing that, it's still, this thing is not less than y, of course. I mean, this is always greater than y, or in the boundary scenario, this is equal to y, but it is always greater than y, right? For any value greater, x greater than 0, this whole thing over here is simply greater than y. So since this is greater than y, we cannot take the minus value, right? Why so? Because we have a square right here. If we take the minus value, this whole thing will be negative, and we will get an imaginary value of the v, which we don't want. Okay, so what we are getting is v equals to square root of g times y plus square root of x squared plus y squared. Okay, so that is the minimum velocity for which we will be getting the requirement fulfilled. Okay, how do we know this is the minimum velocity? Well, think it like this way. The solution of this inequality will yield in something like this: v square greater than this value, or v square less than the negative value. Since we are not taking the negative value, so it is quite evident that we are only getting v greater than equal to, well, let me rewrite this. Since we are not taking the negative value, then v must be greater than this value. So the minimum value of v that is possible is this one. So v minimum should be equal to root over g y and this thing, this monstrosity. Okay, so that was first part of the problem. Now we need to do the rest of the problem. Well, we can do the entire calculation on our own, but we will be doing some sort of trick to minimize the amount of calculation that we need. So the trick shall be, what is the boundary value of v? The boundary value of v is this one, right? So if you put this boundary value of v in this thing, then this entire thing becomes 0, right? Because you are using greater than equal to 0. So if you're putting the boundary value, then you are essentially doing what? You are doing this thing equals to 0. So if you use v minimum as this one, not greater than this one, then you will get this entire thing to be 0. That is, the discriminant will be 0. So back to the original equation, this thing over here, I think I will copy this one as well. Let's copy this one as well. Okay, 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 okay. Yeah, let's go. Let's go, baby. Okay. Nice, nice, nice. Okay. So we have this. since the discriminant is getting 0 for this guy over here, right? Then one thing is for sure, that tan theta will be equal to minus b divided by 2a. We know that for any quadratic equation, if the discriminant's value is 0, then the solution becomes minus b divided by 2a, and both of the solutions are equal in that case. We know all of those basic things. So what is b here? The b is, well, x. So x divided by 2 times, this is the a portion of ours. Yeah, let's put it that way. Okay, so now if we consider some simplification, then we should get something like this: v squared divided by g. So tan theta is equal to v squared divided by, oh well, my bad, tan square is equal to v squared divided by gx. Now, since the value of v is also determined, which is this guy over here, we can put that tan theta is equal to, well, g times y plus root over x squared plus y squared divided by x multiplied by g. You get these things cancelled out. So the remaining portion of the theta is y plus root over x squared plus y squared divided by x. So from here you can easily figure out the value of x, but we can also simplify this thing a little bit more. I mean, we could technically do that, but I don't think that is the purpose of this video. I mean, we could technically simplify this thing. Like, for example, I can tell you how to do that so that you can do that on your own. So think it like this. Think it like this. Imagine there's a right-angled triangle for which y is the perpendicular, x is the base, and obviously then this becomes the hypotenuse, right? So if you divide this thing both in the numerator and the denominator, then you will get something very interesting. 1 plus y divided by root over x squared plus y squared divided by x divided by root over x squared plus y squared. Now, if you consider this angle to be, let's say, alpha, then tan theta becomes 1 plus sine alpha divided by cos alpha, right? So from this, you can easily get a very neat value of theta, which should be something like this. Tan inverse y by x. But that is not the purpose of this video, so we are not going to prolong this anymore, okay? So yeah, okay, now what is left is figuring out the value of the time required for the projectile to hit the object. So how do we do that? That is quite easy, So you know that in the horizontal direction, the object is going in uniform velocity. So we could write x is equal to v times cos theta times t. So we know the value of v. We can also get the value of cos theta. And from this, we can easily get the value of t. So x divided by v cos theta is our answer. We know the value of v, and we can get the value of cos theta from this equation right here. Okay, so that's how you do the solution in the brute force manner. But what is the elegant one? So we are more interested in the elegant one, right? So let's do that. We are going to take help from this equation again, but this time we are not going to convert this in a quadratic equation for tan theta, because this time we're not going to use the condition of real values of theta. This time we have something else in our mind. So as you can see, the problem is a simple optimization problem, right? So for any optimization problem, we try to look at some of the weakest points in the equation, the weakest link, if you may. So look at this equation right here. See, the value of x, y, and g is constant, right? Of course it is. So the value of v is depending on the value of theta. If you can somehow get a function of v with respect to theta, you can then easily optimize the value of v. So that's the plan. We want to figure out a function for v with respect to theta. Okay, fair enough. So how do we do that? Okay, that is quite easy to do. So take a look at this. So we get these values over here, then we divide it with this. That is equal to x tan theta minus y. Okay, so as we can see, the v square is already separated from all of the other things, right? So we can just simply get the v square out of this place and put it there, and we can also get this thing just under the division line. So we have cos square theta right here, and then we have x tan theta minus y is equal to v square. So we already have this format, right? We already have this format, but we can do even better. I mean, we can start from here. I mean, this is already an equation with only theta. The only variable here is theta, so we can just get the maximum and minimum value of theta using this equation, using differentiation or whatnot. But there is a even neater way to do that. So for that, we'll have to simplify this a little bit. So let's multiply this 2n cos square theta with the rest of the thing inside. So if we do that, you can do the calculation on your own. What you are left with is sine theta cos theta, of course. And here we have something like this, 2 cos square theta. Mm, Nothing seems much interesting, not yet, but it will soon be quite interesting. So keep looking. So we have 2 sine theta cos theta. Well, that looks like a formula to me. So we will put something like that. X sine 2 theta. Okay, fair enough. Now, if you look at this, 2 theta, 2 theta, come on, 2 theta. This thing is glitching. Okay, 2 theta. Okay. Now, if you look at this, we have 2 cos square theta. We know that 2 cos square theta is nothing but 1 plus cos 2 theta. So we put that here, and that gives us, well, we have a neater version. Let me write it down again. So v square is equal to gx squared divided by x sine twice theta minus y cos twice theta minus y. So to get a minimum value for this guy, we have to maximize this value right here. As this is constant, this doesn't change whatsoever. So we have to maximize this thing. And to maximize this thing, essentially we have to maximize this thing right here. See, this value will never be less than 0, right? If this is less than 0 and this is also negative, then the whole thing becomes negative and we are getting v square equals to a negative thing. So that is not possible. We need to get a real value of v. Since we need a real value of v, so this thing be something positive. This should be some positive value. So how do we get the positive value? Well, how do we get the positive value? So here comes basic trigonometry. If you have something like this, if you have a function like this function can only have values. Let's say this is a function f of theta. Then f of theta can only assume values within this. This is classic trigonometry. We can we can prove it by doing some easy calculation, but we're going to skip that since trigonometry is not our purpose here. So the maximum value that we can get here is root over a square plus b square. So what is a here? X. And what is b here? Minus y. So what will be the maximum value for this green circle? The maximum value for this green circle should be root over x square plus y square. Well, does it look like the previous one, the previous solution that we got? No, it doesn't. It doesn't. It doesn't look like that. Why is why it's not looking like that? Well, it is not looking like that because it is in a different representation. So if we multiply with the conjugate of this guy, then we get something like this. And then this all of these things simplify to become what we got earlier. B square is equal to g root over x square y square plus y. Okay, so that's how you do it. Now, how do you get the value of theta? Well, that is also easy. You just add them up. You just add this thing up and you get the value of theta. So I'll show you that. I will show you that as well. So how do I copy this thing again? Okay, so we're getting the copy, get a new page, fresh page. Oh hell no. Yeah, drag and drop. Let's go. So for this guy right here, we can easily do something like this. X sine theta minus, sorry, x sine 2 theta minus y cos 2 theta. So we want to minimize or maximize this guy. So for that, what we said was that the maximum value should be this. But how do we prove this? I mean, we are not trying to prove this one. We just are going to figure out the value of theta from this. So how do we do that? That's quite easy actually. So you just divide the value by this and you keep this there. Okay. Now you cannot just divide with something without any repercussion. So you multiply with it as well. Okay. Now you can consider this to be cos alpha, right? If you consider this to be cos alpha, then this automatically becomes sine alpha. So then we have something like this. Root over x squared plus y squared is something like cos alpha sine twice theta minus sine alpha cos twice theta. Then you have, let's call it something else. Okay, it's quite tedious to write this thing again, again, again. So now we have this trigonometric identity, what that we can use. So this is something like sine twice theta minus alpha. Okay, so now we know that if we want to maximize the value of this entire thing, we have to get we have to maximize this thing. Since this is constant, nothing is changing here, so we have to maximize this thing. And when do we maximize this thing? Well, this is quite easy. We can maximize this thing if we put 90-degree inside sine, right? Because we know that sine theta has maximum value of 1 when theta is equal to 90-degree. So we put this entire thing equals to 90, because that's when you will get the maximum value. So then we can write theta is equal to 45 plus half alpha. And what is alpha? If you look at this one, since since cos alpha is this and sine alpha is that, we can easily say that tan alpha should be what? Y by x. So from this we can write theta is equal to 45 plus half tan inverse y divided by x. So that is the solution right there. So this is a much better solution than the previous one, as this requires less amount of rigorous calculation. The previous solution required some rigorous calculation, but this one is, well, this one requires some knowledge of trigonometry. So if we do have that, then the problem becomes a child's play. But even if you have a good amount of knowledge in polynomial stuffs or maybe a quadratic equation stuff, even then the earlier approach doesn't get less messier or something. So I like the second approach because it minimizes the amount of effort that I have to put in if only I know some trigonometric shenanigans. So, anyways, that was from me from for today. I hope that you have learned something new from this problem, and hopefully your concepts are even clearer than yesterday. And until next time, keep studying, keep healthy. Assalamu alaikum.